Energy Cybersecurity webinar. My name is Hassan Al-Tawil and I will be your instructor for this session. Part of this webinar has been pre-recorded either by me or other experts at GE, but I want to assure you that I will be present throughout the webinar to answer any questions that you may have. You may post your questions in the chat box, or you may ask me during the time when we stop in between the subjects, the three main subjects, to take live questions. To get started, let's take a look at the agenda for this course. The goal of this webinar is to provide information about cybersecurity attacks. The three main subjects, the first one will be an overview of the GE implementation of cybersecurity and the historical perspective on cybersecurity. The second part of this webinar will demonstrate the D20 MX and the UR setup as a GE devices on cybersecurity. The third part of this training webinar demonstration, we will show you about CyberArk. And CyberArk is a software that is provided by the CyberArk company, a big player in the cybersecurity world, which provides software that will allow you to configure cybersecurity on the devices for offline access, not only while the devices are connected online. Hopefully you'll have a better in-depth knowledge of that once we are done this training. As mentioned, the first subject that we will discuss today will be an overview of the GE cybersecurity implementation. So the first thing we will cover is a historical perspective. Then we're going to talk about the security requirements. And lastly, we'll cover a universal relay security program for GE Multinet. When I think of data breaches and other types of cybersecurity attack, I form a picture of an attacker in my mind. I guess many people do the same thing, and most often they come up with an image of a pale teenager working from a dark bedroom where the sunlight is never welcome. A teenager who tries to take revenge for his related frustrations and by inflicting some pain into others. Okay. This may have been the truth for some point or years ago in the very beginning of cyber attacks, but not so much anymore. Modern attackers are most often not on their own. They may even be part of a big organization counting into the hundreds of thousands with the precise objectives and clearly defined program. Their motivations are also diverse, and they are dedicated to doing cyber attacks and have dedicated programs and strategies. The motivations behind cyber attacks nowadays are diverse, but not unlimited. Based on the type of attacks historically seen, we may divide them into two big categories: those targeting material gains and those that have an underlying political reason for the cyber attack. The first category is most often seen. Banks, companies, or even individuals are the targets. Only a few days ago, at the beginning of April, a published vulnerability in the OpenSSL cryptography enabled attacks by which passwords, bank informations, and even social insurance numbers of many have been stolen. The vulnerability has been fixed and the systems at risk have been patched, but the speed by which the cyber attackers act is amazing. In a matter of hours, they already had programs to exploit it to take advantage of the attack, take advantage of the system's flow. Cyber warfare is very serious matter these days, and countries around the globe spend important resources in an effort to prepare their cyber defense to be ready for any possible attack. The communication infrastructure in the electric grid has been evolving rapidly in the last decades due to the need of transporting an ever more sophisticated information, both data and control. For the first dedicated lines of communication between transmission lines, terminals, it evolved to point-to-point connections, then system-wide network with fixed architectures such as rings, fiber, carrying sonnets TDM, data frames, and more recently Ethernet-based networks. The modern relays are complex embedded systems fully capable of communication over Ethernet, local and wide area network to exchange information with SCADA systems, controls and dispatch centers and centralized management systems. The benefits of Ethernet networking are huge. Flexibility and ease of deployment are only two of them. However, networking comes with features that protection engineers need to be aware of. If they wish to take full advantage of its capabilities, it also comes with a new challenge that protection engineers might be aware of. Okay, so I'm going to talk about the Ethernet and its benefits. As you can see, it's mature, low cost, high speed. The greatest benefit of using an Ethernet is that an Ethernet path can carry a mixture of traffics, different traffic types at any time without requiring rewiring or manual reconfiguration for that purpose. In a typical substation installation, the Ethernet network replaces bundles of dedicated control and communications wiring. A variety of data packet types are using the same network to carry out a full range of functions. Example, DMP3 packets may be transmitted to a SCADA system with all the information. An HTTP application residing on the laptop can collect and display statistics from IEDs. A file server residing on a PC communicate with IED using FTP protocol. If at some later time an application that communicates with the relay using Modbus protocol is installed on the laptop, there is nothing to be changed. No more wiring, no more configuration is needed. If the relay understands the traffic, and that means that the entire system all works and no rewiring is required. Any number of data traffic exchanges can be mixed on any network path, and all information will go where it should be delivered without loss, as long as the overall bandwidth of each path is adequate to handle the largest volume of traffic that may pass through it. Each pack contains all the required information on what its content is and where it is intended to go. Common mechanisms for access. The devices may use the same Ethernet IP and hardware mechanisms. Devices from different vendors can communicate, and one good example of that is the IEC 61850 protocol, which is achieving interoperability between fast devices. Okay, so basically with the implementation of Ethernet that we've seen the benefits, it also introduces some level of complexity, and as it adds complexity, it requires its own engineering and configuration, which in part means that we have to have a new set of skills for the engineering force. It also introduces some of the problems that it will introduce. It's like signal latency, transmission line noise, channel line availability. It's essentially a target for cyber attacks. So in this section, we're going to discuss the security requirements and how to overcome some of these security requirements. Okay. Before we go too far, I would like you to take a look at these acronyms. First, NERC, which stands for North America Electric Reliability Corporation. CIP, which stands for Critical Infrastructure Protection, and CIPC, which stands for Critical Infrastructure Protection Corporations. The CIPC standard is known by the NERC CIP sometimes, and for the NERC CIP requirements, support from the applications like the UR relay is needed in order for the utility or the company to implement the full NERC CIP compliant solution. Okay. So among the requirements for the NERC CIP compliance is the RBAC, or role-based defined access, or as roles define the level of access or authority, authorization of access to for the device's operations. We're going to give an example of the RBAC access in the universal relay. So for the UR relay, the first access, as you can see, is the administrator. So the administrator has complete access, right? The administrator have the ability to read and write all settings and commands, all security settings, right? The next level that I'm gonna discuss is the engineer. The engineer has complete read and write access, with the exception of configuring security settings and downloading firmware. Okay, so these two things are not allowed at an engineering access level, which is configuring the security settings and doing a firmware upgrade. The next access that I will discuss is the operator. The operator access has a read-write access to all the settings under the command menu section. This role shall not exist offline. Okay. I've skipped over the supervisor setting. This is mostly an approving role. The role unlocks the relay setting changes. Additionally, the supervisor has the right for enabling cybersecurity settings, basically to the bypass mode, enabling the factory service mode, forcefully logging out any other role and clearing the security event log. This role can be disabled, but only through supervisor authentication. When the supervisor role is disabled, its permissions are assigned to the administrator role, right? Once we disable the supervisor role. The observer, which is the least of roles, has read-only access to all UR setting. Observer is the default role. It does not require a password. It is practically equivalent with just reading access, a simple reading access or no access. The factory role has complete read and write access. This factory role is not listed as normally it is not in our released software that we give to our utilities or our customers. This is intended only for factory use. It is not available on the release product. So basically the CYP-10-1 part 1.2 authorize and document changes that deviate from existing baseline configuration. So the solution is a security event reporting through syslog protocol for supporting security information events, and open source syslog software is available on our appliances or our devices. Another NERC-CYP requirement example, a process to initiate removal of individuals, ability for unescorted physical access and interactive remote access upon the termination action, and complete removal within 24 hours of being terminated. So in order to carry this removal of access within 24 hours, this implies that for a large number of employees with a large number of relays, it is very hard to be done at every relay. So it has to be done from a centralized management or a centralized location where all the users and their credentials are kept and managed in one single place. Hence, removing one person credential is done at this single place. So the solution option for the requirement of removal of access upon termination, in this case, I guess some of you have heard of it, it's the Radius server, which is known in the world of networking. So Radius, or better known as remote authentication, dial-in user services, can be used. As you can see, basically we've got a Radius server and a device that can interact with a Radius server over a network physical connection. So the device would always check with the Radius server for any network access and for any authentication of password, and the Radius server would either authenticate or de-authenticate the user. Okay, with the security requirement being discussed, in this section I will discuss the overall GE Universal Relay Security program. Okay, so GE Cybersecurity framework, named basically CyberSentry, has been defined as a comprehensive, multidimensional program that provides cyber security through multitude of methods, all aiding toward the ultimate goal of delivering robust, secure devices to our customer. There are three main aspects of this program, which covers, as you can see, security through process activities and automated security testing that ensure that the flaws in the design and coding are detected in the development phase of a product. GE uses the Coverty statistic code analysis for unit testing of the code. Another Waldrich Axials vulnerability scanner for cybersecurity and communication robustness. MU dynamic testing test tools for a variety of protocols such as DMP, Modbus, 61850, Aegis by Automatic is also used for DMP testing. Okay, that's for basically a server vulnerability in the DMP client has been uncovered using this software. Security through prevention, which focuses on precautions taken so access to devices is controlled and data traversing public networks cannot be captured and read. Centralized authentication with user-defined and maintained on central servers such as Radius, role-based access control, and encryption of data, as mentioned, are features in this category that are already offered. The communication between the UR relay or the GE device and the Radius server uses EAP TTLS, which provides user password authentication while the password credentials are transported in a securely encrypted tunnel. The communication between, for example, the UR relay uses the Inner Vista software. So the communication between the Inner Vista program and the GE ID, such as a UR relay, is all SSH encrypted. Or for those people who are not familiar with the SSH acronym, stands for Secure Shell Encrypted. As mentioned before, the cybersecurity requirement for role-based access, all the roles are password protected, except for the observer role, which we said is equivalent to none. A user with observer capability defined on Radius is password protected. All the roles except for observer, including device and server authentication, accept only one session at one time. Only observer allow multiple concurrent sessions. The maximum number of concurrent session an observer can support is equal to the maximum number of Modbus connections to the device, which in this case, in the case of the UR relay, it's 4. Strong password complexity is enforced adhering to the following rules. Password cannot contain the user's account name or parts of the user's full name that exceeds 2 consecutive characters. Passwords must be at least 6 characters in length. Passwords must contain characters from 3 of the following categories. English uppercase characters A to Z through Z, English lowercase characters A through Z, base 10 digits 0 through 9, non-alphabetic numeric, for example, you cannot use exclamation mark or $ or hash sign or percentage. Okay. Server authentication using Radius is a preferred method as it allows individual users to be created, assigned a role, and managed centrally. With when no Radius server is available for performing centralized authentication, you still can use the RBAC system or the role-based access authentication. In this case, a number of 5 users are available offline and are managed locally on the device itself, which users correspond to the defined role and carry the same names of the roles. In this case, we have the administrator, supervisor, engineer, operator, and observer. Okay. By default, both devices both device and server authentications are enabled, right? So when we lose the connection to the main server, then the device can authenticate locally based on these 5 roles. Okay. The 2 screens that we show in this slides are the login screen for UR, and as available, login with the device authentication is available. Also, from the front panel of the UR, logging in for server authentication is available through the Inner Vista software. By default, both device and server authentications are enabled, and the device authentication is chosen as in the right screen. Since the possible users are predefined, in this case all of them are presented in a drop-down menu which allows for a choice. Once the user is chosen, a password must be entered and the authentication is performed locally on the UR. If server authentication is desired, which means that the user would like to log in using Radius server authentication, so of course a Radius server must first be deployed and configured and users added to its database. Additionally, information regarding the server must be configured on UR. We will talk about this in the next section. Once everything is configured, the server is configured and the server is reachable, a user may log in using the server authentication mode by choosing the server authentication type on the login screen and entering their username and password. So as per the previous slide, right, as you can see on the left, the authentication is then sent through the UR Radius server where it is authenticated. Device authentication may be disabled. In that case, the login screen will default to server authentication. but the option to log in with device authentication is still available for administrator or supervisor for the purpose of switching the device authentication back on when needed to be only device authentication or just server authentication. The supervisory screen mainly is used for configuration settings that are available only to the supervisor. If the role is enabled or the administrator can disable the supervisor role. Supervisor role enables or disable this roles. If disabled, an administrator role will have access to all the settings that is available on this page. The supervisory screen lists mainly configuration settings that are available to the supervisor. If the role is enabled or the administrator is if it is disabled, then the administrator will carry out the supervisor role. The administrator also, as I said, can disable the supervisory role. The device authentication may be disabled from this page on the UR relay also. So commands are accessible to supervisor, basically forceful logout of other roles, clearing the security log. Commands accessible to administrator is load factory defaults in this. Okay, so remote authentication, our radius, basically remote authentication dial-in user service radius, as I said before, is a network protocol that provides centralized authentication, authorized and accounting, 3 A's, AAA. Management for users that connect and use a network service. It's a client-server protocol that runs at the application layer of the TCP/IP stack using UDP as a transport layer. UR implements a Radius client that communicates to the Radius server for the purpose of authenticating users, as we've seen in the roles before. The communication between the UR and the Radius server, as we said, is over EAP TTLS encryption, which provides password user authentication while the password protection, while the password is transported encrypted in a securely encrypted tunnel. The UR must configure the parameters required for communicating with the Radius server. The configuration is available on the main security screen. Primary Radius IP address, as you can see here on the screen. In this case is 000, but probably you will set it to the IP address of the Radius server. And Radius UDP authentication port is important, so that needs to be also configured. Primary accounting port for the Radius accounting may not be used. The vendor ID, an identifier that specifies the Radius vendor specific attributes used with the Radius protocol. It is IANA assigned. GE has a vendor ID of 2910, as you can see on the screen. So, as mentioned in this area. Also, you need to configure not only on your Radius device, on your Radius server, but also in the UR relay, a shared secret, or a shared secret word sometimes is referred to in the authentication. It is only displayed as asterisk when you're inputting it into this interface, so to meet cybersecurity password requirement. The security page also provides the means for changing the passwords when working with the device authentication, for configuring the session lockout parameters, number of missed authentications for the lockout and the lockout time, and the syslog server IP address and port number. So the request containing the username and password is sent from the EnerVista PC program to the UR through an SSH, or a secure shell tunnel. The Radius client residing on a UR creates a UR access request message. When the reply is received from the Radius server, the Radius client on the UR has to send this information back to the SSH server residing on the UR. The SSH server in turn will send back to the SSH client on the EnerVista. I think this concludes our discussion on the overview and the GE program. Hopefully this have given you a quick introduction into the historical perspective as to why this security requirement has been implemented. How did it come to surface? How was it hand in hand with the Ethernet implementation in the substation? We've also shed a little light on where the security requirements are coming from, some of the acronyms that are used in a cyber sentry or security, and how the GE Universal Relay Security Program work. We give an example of one of the GE devices, which is like the UR relay device. At this point, we'll open the phones for a Q&A session where I'll try to answer some of the questions that came online, or you can share your questions in a live discussion with me, and I'll do my best to answer your questions. Okay, so thank you very much for your questions. I guess the first question that I've seen was what's the maximum number of users that can be configured? The maximum number of users in a Radius setup depends on the number of the capacity of the Radius server. So the Radius server would specify what is the maximum number of users that can be configured. Another question that came through is, do we really need to set up the substations on an internet setup? And the answer is no. You can have it all set up on your intranet or your own network. So you can have the Radius set up inside your enterprise or your company, and then you will have the substations connected to your company IT servers. It doesn't need to be open to the internet. Another question is, do we need a Radius server if we have a firewall? And the answer is yes. What the Radius server does is it centralizes the authentication of users and from a single point, and then you can ease the management of passwords for these users as they join or leave the company or the utility. I think I've answered all the questions that were raised. Any other question that I missed, or any concern or comment you would like to share? Okay, all right, we'll start and we'll give you a 1 minute break, and then we will start again in 1 minute. Thank you. So in this section, we're going to show you how to integrate the D20 MX with a free radius. The steps are very simple. We install a free radius server, which is available for download. The reason for us picking the free radius is because it's easy for this demonstration. Of course, if you're doing it in a utility, you would do it with the Microsoft radius, where your IT team would set up the Microsoft radius server. But just to show you how the radius server interact with a D20 MX, we're going to basically install a free radius, install the certificate application, and then install and then show you how SG configures the D20 MX to work with this free radius. So the first step is to install a copy of the free radius server. This free radius server, I'm going to install it on this computer that I have here. I've downloaded a copy of free radius server 2.2.0 x86. You're welcome to download the latest copy. There's other copies of the free radius that basically are more friendly or Windows friendly free radius. Okay, so this is the installation of the free radius setup. We start it up, click run. As you can see, it's going to install to the C drive free radius, and it's putting all of these folders, the etc folder, sbin, and all of that. And the installation, as you can see, of the free radius is pretty straightforward. So the free radius installation is done. We get a notification after the installation of the free radius. So another software that we would need to run is the certificate generation software. Click yes, click OK, and click agreed, next. And now this certificate generation software is available if we need to generate certificates. Okay, so once you have installed your free radius and your certificate reading software, what you need to do is you need to create, as per the document called Integration of Free Radius Server with the D20 MX. The document number is SWM0077. You can get it from our technical website, customer service team. So to go through the steps that's in this document, I'll just show you the steps that's in this document. I mean, you're welcome to either follow the documents or follow this screencast. Either way, you'll get to set up the free radius. Now, all of the steps that I'm going to show you are normally set up by your IT personnel. They would set up the radius server, but in case you have to do a small test at your desk in order to see how this radius authentication work with a free radius, then you can do it using these steps. All right, so the first step in the document, it says you have to edit a file dictionary.ge, and basically you have to write it in a certain manner. So every device in the world would have a certain definition dictionary available in this directory. So basically, I'm just going to show you how in the directory that says C free radius etc raddb dictionaries, in here we will add dictionary.ge file, and this dictionary.ge file need to be written like this. So it will have the vendor GE2910, begin vendor GE, attribute D20 MX user role, let's say 1 integer, and then it puts the value for every role, right? So this is, like I was saying previously, that this is a role access based RBAC setup, right? And every role would have a certain digit allocated with it, and that's the common between the server and your device, the D20 MX device in this case. Okay, the next step is, once you have finished setting your dictionary, you would have to go back and edit the under etc raddb. Okay, we would have to edit the user's file. Okay, so this user's file, and to edit the user's file, you basically adding your users, the name of your user, and the password of that user. Okay, name of every user, so an operator user, an operator password. But what the recommendation is in here in the radius, you wouldn't do this. You would put the real people names, right? Like John, Hassan, Jack, whatever you want to put in here. Okay, and real passwords for every user. And for every user, you would have to specify the role of that user. Okay, so we're specifying a D20 MX role as an administrator for this user, admin user of password admin BW. Okay, the next step based on this document is to edit the file client.conf, right? Client config, and you're basically putting a test. Remember this secret word. This test secret word is what we're going to put in our sgconfig wsmain tables, right? In order to make sure that the D20 MX and the server are going to exchange this secret word at some point in order to do the handshaking, right? So without the proper secret word between the D20 MX and the server, that this server will not accept any authentications from the D20 MX. Okay, and then the next step is to edit the file, which is under radius. It's, forgive me, sorry about that. The EAP conf file under etc raddb. Okay, so the EAP conf file under here, this one, and if I open it up, so in this EAP file we're going to do a TTLS as an encryption for the name and password that's going to be sent from the D20 MX to the server. And also we're going to, under the TTLS section, right? We're going to enable the CHAP v2, and we're going to set the copy request to tunnel, yes, and we're gonna set use tunneled reply, yes. I think that when I installed it, by default it was set up this way. If not, then you would need to set it up to these parameters. If the document has an option for PEAP, it's up to you whether to set it with EAP TTLS or PEAP, right? This is different encryptions, and honestly it depends on your utility philosophy and advisory of the IT team of your utility as to which encryption to use. In this case, we're using the EAP TTLS. All right. The job is done as far as configuring our server, and what happens is once you are done all of these files, you save them all, right? And then all the files inside your Radius server are ready to run. So basically, to run this Radius server, we just click on Start, click on All Programs, go under the free Radius server 2.20, and there will be Start Radius server. The Radius server starts like this, right? It just it says ready to process request. So it's waiting for a device to send a request to it in order to process the request and return back to the device whether the customer or the person that's coming into the Radius server is authenticated or not. Okay, so what we're going to do is we're going to start with sgconfig configuration as per the document. So we open a device. In this case, I'm just opening a default device. We open the wsmain configuration tables. And in the wsmain configuration table, there is a couple of tables that are involved here. The first one is the Radius table. In the Radius table, you want to put the host name, and the host name would be the host name that we configured as the address of our Radius. So just to take you a step back, let's say that the address of my server is 10.14.46.15, which is this PC, basically where I have the Radius running. What I have to do is I have to make sure that when I edit the properties of this device, under the hosts table, that we add a name for this Radius server and an IP address for this Radius server. So in this case, it's Radius 10.14.46.15, which is the same IP address that I have for my PC that has the Radius up and running on it. Of course, the D20 MX is on the same network as the Radius server, so the IP address of the D20 MX also need to be within the same class as the PC that you're running. Okay, and I'm opening the wsmain. So I define the name Radius for the address 10.14.46.15. I go into my remote servers. I put the same exact name here that I had in my host tab. Then we use this shared secret. So the shared secret basically allow us to this is the same shared secret that came from the client.conf file that we configured in our Radius server. So we have test.test123, right? And in this case, we are putting the same shared secret in both files, okay? We can set up the encryption. In our case, we've said that the encryption is going to be EAP TTLS, and that's what we configured in the server under the EAP conf file. All right. And then for the authentication, we go to the authentication info, we select CA certificates, and the certificate, in this case we're selecting the first certificate. Based on the documents, you would select PEM file 1, right? And that's where you need to get the name of your encryption. So to do that, you would have to run the software So I will go to my free radius, go to the etc raddp, open the certificates directory, and then it says here that you would have to look at the common name of the server.pem. So when I go open, that's the second software that we installed today, right? And I go details. Okay, we can see that this is the name, or the internal name, the common name that's available. So I can copy that and basically insert it back in my X509 file. All right, so we'll just paste it in here, right? And we click OK. And now we have configured our common name as per the document. The next step is to take the root CA file .pem as per the document, copy it somewhere. So I'm just gonna make a copy of it. I'll copy it to my desktop. Okay, and what they're requesting is that per the document is to rename it to PEM file 1.csv. So you are naming it to the same name as the name of the certificate file in Westmate. Okay, so I'm gonna go to my Westmate. And then we're gonna go to the PEM file, and in here you've got two files depending on how many certificates you would like to import and what's the setup. So we'll go to the first PEM file, right? And let's say there was nothing in here. Okay. Okay, so now it's empty. What you would need to do is import in this CSV file that we just created, or comma separated version file that we just created. And to do that, we just go back into sgconfig, click on the import, we select our PEM file CSV, click open, and this is the encryption, which is an exchange, a certificate that's exchanged between the D20 MX and the server, so that whenever there is an authentication that goes on, the server will request this certificate from the D20 MX to make sure that the source of the information is the right source. So, and that's it. You would configure your PEM file. We are done our configuration that's required for the D20 MX to be certified with the server. So we can generate our configuration. Okay. Now, once your terminal emulator is open, you cannot generate. So And the recommended generation is 100% generate, so we'll do 100% generate. It's prompting me that it has to close the project before it can finalize all the generation. And here, the generation of the SHX file or the configuration file is taking place in the database. Now we can connect to our device. So I'm connecting to the device, to the D20 MX. And we download our configuration. Now, this configuration contains the certificate, contains our secret word that's shared between the free radius and the D20 MX. It also contains the common name of the certificate between the two devices, and that's the only change from our previous normal Westmain to the new Westmain is the addition of those parameters that will allow you to integrate and communicate with Radius server. Okay, then we boot our D20 MX. Now the thing about Radius is, as long as the Radius server is up and running, right, the D20 MX will rely on getting the authentication of whoever is logging in from the Radius server. But once the Radius server stops running, right, it's not connected to the D20 MX, or the D20 MX cannot reach it, then the D20 MX resorts to checking the name and password locally, right? So it will check its own local database of name and password. So for example, right now I stopped the Radius server from running. When I log into the D20 MX, I can type the default admin change me name and password, and the D20 MX will try to find a Radius server. If it cannot find a Radius server, it will log me because I have the right credential for a local access. Again, the local access will be covered in different videos. It also can be controlled using technology like CyberArk technology, where that can constantly change the name and password so that you also have protection when you are in local mode, not only. And the other recommendation is, if you don't have something like the CyberArk up and running, is to make sure that the local username and the Radius username are totally different. So you can't have the same user on configured as a local user and as a remote user, right? But just to demo the Radius functionality, so I'm gonna start my Radius. Again, I go to Start, All Programs. I'm gonna do this in a terminal, so I'm gonna take out, gonna close, just to give myself more real estate here. So I will open it in a terminal emulator. Okay, so as you can see, we've got a terminal emulator here that's connected to the D20 MX. At the same time, I will start my Radius. Okay, and as you can see, the Radius server is up and running based on the users that we have defined in the Radius server, right? The first user the name will be admin user admin BW. So if I try the local admin change me, right? This goes back to the Radius. We see activity on the Radius server and it gets rejected. It logs me off. It doesn't allow me to go in. So if I try to use, I'll move this a little bit to the side so that you can see it. If I do the admin user and click on admin PW, we can see that the Radius server received a message and confirmed that we can start this session, that me as a user, I'm allowed to access it over the network. Also, any of the other users that we have configured, so we'll do another access here. If we go with operator user and OPPW. So I have an access. Not only does it tell me I have an access, it also tells me what role am I access. So in this case, I'm accessing it in an observer setup. So as you can see that setting up the Radius is not so difficult, and it has been simplified in the D20 MX. I hope this has given you a good insight into the setup of free Radius with the D20 MX. If you have any questions, hopefully you can share them either with myself or with the technical service team in the future. So next we will show you how to do the UR configuration. Okay, so in this video I'm going to show you how to set up the UR with the free Radius, and we are following the CyberSentry setup that is available in the UR manual. The UR manual is available from our website, and we're not going to do much changes from what we did on the D20 MX setup. It's basically the same. So I'm just going to go through the steps of setting up a UR device with the server. So to do that, the first step is we're going to start the UR software. If you're not familiar with the UR Inner Vista software, there is other screencasts that we have recorded on that, and you can watch it on the YouTube. So I start the Inner Vista software. It will ask me for my name and password to start the software. This is a feature that has been added lately, and you might require it, you may not require it in your system. So this is the UR software, and I've got my UR with an Inner Vista, with a cybersecurity option built into it. So you can purchase the UR with the cybersecurity software or without it. In order to enable the Radius features, you would have to make sure that the cybersecurity is part of your ordering code. For ordering code related information, you can find it on our website. Okay, so what I'm going to do right now is I'm going to basically try to open the Radius software, the UR device, and when I start, it will ask me for the default password. If this is the first time you're opening the UR, per our manual, the default password is change me #, which is recommended to be changed once you install the UR on the site. So I'm just gonna paste in this password, click connect. Right, and it's gonna give me access to the UR device. I will go to settings, product setups. Now, of course, we're continuing from our previous installation where we have the free Radius server already installed. Okay, and in here, we're going to access the security. In the security, we have to put the address, which is the address of your Radius device or the free Radius server. So in my case, it's 10.14.46.15. we have to put the EAP TTLS and the shared secret word. So based on the free radius configuration, okay, and if you want to find out what to set up the free radius configuration, like how I set up these files, from the manual, if you go to the free radius, to the radius setup section, okay, in here it clearly specifies what to do for every part of the radius setup. Okay, so for example, it will ask us to access the clients, make sure that the address of the device is clearly in here. So basically, if I go to the device setup, device definition, right, we can see that the address is 10.14.4620. okay, so we have to put the address 10.14.4620/24. we put a shared secret word, right, which is test123. This shared secret word is what I would put in here. So if the radius authentication shared secret word, I'll make sure that I have the same one in here, test123, and then we'll type it again, test123. Okay, so now we have the same shared secret word. The other thing that we need to do is we need to make sure that the address is proper and the vendor ID is proper. So in the dictionary is 2910, or if you follow the manual, it says this is the way the vendor dictionary should be written. So for a vendor, GE ID 2910, right, and the attributes, GEUR role 1, GEUR role, we've got the administrator role defined as 1, supervisor role divided as 2, engineer role divided as 3, operator role defined as 4, and observer role is defined as 5. Then you can start to add your users to the users file. In the users file, we will have the same admin user. We'll define our GEUR role as administrator with a password admin PW. Okay, once all of that is set up, okay, we can close out of here, disconnect our radius, disconnect our administrator, run the radius server, okay, and now my radius server is ready to process a request. So when I try to access my device, it asks me whether I want a local access or a server access. So for people other than the administrator who can access the device locally and then probably the administrator have already set up his own password locally, he would go through a server access, and through the server access we'll use the name and password. So we can use now admin user, admin PW. Click connect, we can see activity on the free radius, and it's basically authenticating the user. And the user has been authenticated. Now we can access as an administrator the device again. If we, for example, entered an improper name and password, so let's say disconnect, and I go try to open it, go to server, put an admin, click connect. Okay, now the radius server is running, right? and it prompts the user again for input because we have put an invalid input, an invalid user that's not on our user's configuration file. So hopefully this have given you an overview of how to set up the free radius with another GE device. Okay, so in this screencast we have shown you two devices of GE, the D20 MX and the UR, and we have shown you with the D20 MX how to install the free radius, how to install the certificate program, and how to configure the free radius and the certificate program inside sgconfig, and how sgconfig can basically update the information of the D20 MX and the D20 MX interacting with the free radius to authenticate users upon users login. The second part of the video of the screencast, we have shown you the universal relay and how to configure it with the Inner Vista software, and they follow the same method overall. Basically have a shared word or a shared secret word, and how to configure the free radius in order to define all the roles of different users and then define those users, their names and their passwords. So this, as long as the free radius is connected, the user will be able to connect via the server. Otherwise, somebody has to be dispatched to site in order to reconnect back to the radius, and that person should have administrator access. Okay, so I will open the phones for any questions and answers. Thanks. Okay, so one of the questions that I received is, can you access as observer and engineer at the same time? The answer is you can simultaneously access as so simultaneously you can have one administrator, one engineer, one supervisor, and as many observers as the system can take, but you cannot have two engineer role accessing at the same time or two administrator roles accessing at the same time. And that's per device. So if you have more than one device in your site, different engineers can access different devices on the same site at the same time simultaneously. Hopefully that answered that question. Another question is, does the SCL-61850 implementation include the encryption setup or the radius setup? The answer is no, it doesn't include it. It has to be pre-configured in the devices. Okay, any other questions or thoughts at this moment? Okay, so we'll give you a moment and then we'll start our last session on CyberArk. Okay, so the CyberArk, how does it work? And what does it mean to us as users? How does it impact our cybersecurity overall program? The CyberArk is the only security company that has provided protection against cyber threats to any enterprise. There's about 1,400 global businesses that trust CyberArk security system, and it can basically, with our GE devices, it will allow us to change the offline password. So with the free radius, we have seen how the online password has been managed. What if you have many administrators and you want the offline password? So when one administrator leaves the company for any reason, and that name and password is not protected anymore, well, how do we manage that? How do we manage the offline name and password, and we change it from a central point, and make sure that that name and password is used only in emergency situations or in situations where the device can no more access a radius server. Okay, so the way the CyberArk work is that once the device connects to a network, it will be connecting to the radius and authenticating users via the radius. And with the CyberArk technology, a new password will be installed on the new name and password will be installed on the device based on CyberArk scripts that are encrypted and are updating the name and password on that device. And basically, the device would request an offline name and password for someone to log into that device. In the demonstration example, let's say that we've got this D20 MX, which is sitting in the substation. We've got a network that's connecting the D20 MX to the radius server that's at the utility or at a managed IT place. And also this D20 device is connecting to the CyberArk services. The CyberArk, once it's online with the device, it would update a secure offline name and password on the D20 MX. This secure offline name and password is stored on the vault of CyberArk services. And let's say that along the way we have a disconnection from the network. So now we need somebody to be dispatched to the site in order to connect to our D20 MX and start to re-establish connection to the network again. Well, in order to do that, he would need to get in contact with a CyberArk representative. The CyberArk would, this person would request access from the CyberArk person. The CyberArk person would authenticate this person for access on the network, and then would provide him with access credentials that he would have received from the vault or the CyberArk vault. This person will in turn use these credentials, the name and password, and access the D20 MX and restore connection to the network. So once the person leaves the site, that person have established that this person has almost set up the D20 MX for site access, for network access. Immediately, that name and password that was given would be changed in the vault, in the CyberArk services system, and a new access would be updated, a new name and a new password would be updated inside the vault. And when the D20 MX is again online with the CyberArk, a new name and password would be installed on the D20 MX. So as you can see, the new name and password are different from the previous name and password that was used, and it's an immediate update once the device is online again. Once that person leaves the site, even if he used the same name and password that was given to him by the CyberArk representative, that name and password is no more useful for offline access. For online access, again, it will use the radius server. So it's a very simplified setup and service that's provided in order to give the utilities an option to manage the offline name and password, not only the online name and password. So the online name and password will be managed by the radius server. The offline name and password will be managed by this CyberArk technology, where that name and password goes into the CyberArk secure area that is accessed only by their employees upon request from the site, with proper authentication of the person prior to giving him a name and password. And once that person have established communication, immediately the name and password would be changed for that device that's on the site. This is a very useful technology in order to simplify the management of offline access to the GE devices. So in this screencast, I have shown you an overview of the GE program. How does it work? How does it apply to our cybersecurity central for the devices. I have also shown you how to basically configure the D20 MX with a radius server that would allow you to manage your users offline and online, and with the universal relay, how to manage the users with a radius server for online access. The CyberArk shows you how to set up the users for offline access, and it's a very secure setup that will allow your enterprise or your utility company to manage offline access with various administrators in the system. So it is a very secure way and an advantage to your utility to basically secure against any cyber attacks on the devices. Our main goal in GE is to make sure that if you need this facility of accessing your sites remotely or opening the site for remote access, that it's done in a very secure and utilizing the latest technology available for security. I hope that you got what you were looking for from this webinar. I will open the phones for a final question and answer session. Please feel free to share any questions, comments, and I appreciate your visit. Okay, well, thank you very much. One of the questions that came through is, does the CyberArk setup need to be set up away from your enterprise or away from your company? And the answer to that is no, it doesn't need to be set up away. It can be set up inside your inside your IT department, and it can be managed within your IT department. As such, the services are available within your intranet, and you don't need to open your substation to the internet in order to implement this CyberArk technology. Okay. Any further questions, thoughts, or anything you would like to share at this point before we end and close this training?